Hello and welcome to Controllers Tech. This is the fifth video in the ADC series of the STM32. In the previous videos we saw how to read the multiple channels of the ADC using the DMA. We used the DMA in both normal mode and circular mode to read the multiple channels of the ADC. Today we will see how to do the same, but without using the DMA. Although there is no reason for us to not use the DMA while reading multiple channels, but since there are ways to do it, we will cover them. We will first use the method of discontinuous conversion mode to read one channel at a time. Later we will modify the pre-generated code itself, so that we can read any random channel at any point in our code. Here I have already created a project for this tutorial. The 4 channels are enabled, just like we did in the previous videos. The ADC clock is configured to run at 15 MHz. Let's configure the parameters now. I am using a prescaler of 10, so to reduce the ADC clock to 1.5 MHz. Now the first thing we will do is set the number of conversions to 4. This will automatically enable the scan conversion mode, which is a must for the multiple channels. As I mentioned, we will use the discontinuous conversion mode first. This mode is actually used to split a longer conversion queue to smaller queues. For example, if we have 10 channels to be converted, we can convert 4 channels at once, then another 4 channels, and then the last 2 at the end. But we can also use this feature to convert 1 channel at a time, therefore eliminating the need for the use of DMA. So enable the discontinuous conversion mode, and set the number of conversions to 1. This will split the queue of 4 conversions to 1 channel at a time. Also make sure that the end of conversion selection is set to the end of single conversion. We want to read the data from 1 channel at a time, therefore it is necessary. Set the conversion data to store in the data register itself. Now let's configure the ranks for each channel. Although we are using discontinuous mode to read a single channel, we will still not have the option to choose the channel to be converted. The channels will be selected as per the rank we configure here. Alright, I have configured the ranks and sampling time for all the channels. We are not using the DMA and the interrupt for this tutorial. We will simply use the polling mode to read the multiple channels. That is all we need to configure. Click Save to generate the project. Let's take a look at the configuration required for other MCUs. Here I have the configuration for the F103C8. I have already enabled 4 channels to be converted. Now the first thing we will do is set the number of conversions to 4. This will automatically enable the scan conversion mode, which is a must for the multiple channels. Enable the discontinuous conversion mode, and set the number of conversions to 1. Now you can configure the ranks for the channels according to the sequence in which you want to convert them. Let's take a look at the configuration required for the F446RE. Here again we will first set the number of conversions to 4. Now enable the discontinuous conversion mode, and set the number of conversions to 1. Set the end of conversion selection to single channel. Now you can configure the ranks for the channels according to the sequence in which you want to convert them. There is not much change in the configuration required in different MCUs. Alright, let's write the program now. Let's create a 16 bits array of 4 elements, to store the converted channels data. We will repeatedly convert the channels inside the while loop. Start the ADC first. Then poll for the conversion to complete. Here I am setting a timeout of 100 milliseconds. Now we will read the converted channel data, and store it in the 0th element of the array. Now remember that we should not stop the ADC, rather start the ADC again, poll for the conversion to complete, and read the converted channel data. We need to repeat the steps for the number of channels we are converting. The sequence in which we will get the results is based on the ranks we configured in the CubeMX. Once all the channels have been converted, stop the ADC. Let's also give a delay of 250 milliseconds before starting the conversion again. Note here that we cannot choose which channel is to be converted, we need to read the data in the same sequence as we configured the ranks in. This is how the 4 potentiometers are connected to the MCU. All the potentiometers are connected to the 3.3 volts, and the ground of the MCU. The middle pins of the potentiometers are connected to the ADC channel pins. Alright, let's build and debug the project now. I have added the ADC value array to the live expression. Let's run the debugger now. You can see that we are getting the data from all 4 potentiometers. They are changing every 250 milliseconds. I am going to fast forward the video now. I am rotating the first potentiometer, and you can see the variation in the 0th element of the array. I am leaving this value at around 50,000. Now I am rotating the second potentiometer, and you can see the variations in the first element of the array. I am going to leave the value at around 40,000. Similarly, rotating the third and fourth potentiometers varies the second and third elements of the array respectively. So we were able to read multiple channels using the polling mode, and without the use of the DMA. Although if you see the code here, there is no point of doing it this way. Since we have to read all the channels anyway, so why not simply use the DMA? We can stop the ADC after reading just 2 channels, so the rest 2 channels can be avoided, but if you want to get the data from the 3rd channel, you still need to read the first 2 channels. As I mentioned earlier, the discontinuous conversion mode has an entirely different purpose. We can use this mode to read a single channel as we did just now, but practically this is not its purpose. I will make another video showing the actual purpose of discontinuous conversion mode. Now we will see another method to read the multiple channels in the blocking mode. Let's open the CubeMX to modify the project again. Let's disable the discontinuous conversion mode, as we are not going to use it anymore. The rest of the configuration will remain the same. The scan mode is enabled, as it is needed for multiple channels. Make sure the continuous conversion mode is disabled. The end of conversion selection should be set to the end of single conversion. This will make sure that the conversion complete flag is set after a single channel is converted. Let's generate the project again. I am going to refresh the project, so that the new configuration is visible. Let's comment out this part as we do not need it anymore. We need to copy the data from the ADC initialization function. This is where the channel configuration starts from. Let's copy the configuration for the rank 1. Now we will create a new function, ADC convert rank 1. Paste the channel initialization part here inside it. This code will basically configure the ADC channel 3 with rank 1. The sampling time is configured as per the CubeMX. After the channel has been configured, we will start reading the channel. To do so, start the ADC first. Then poll for the conversion to complete. Read the ADC value, and stop the ADC. Since channel 3 is configured with rank 1, we will get the data for channel 3 itself. Also remember that we have configured the end of conversion selection to the end of a single channel. Therefore the conversion complete flag will be set after each channel is converted, and hence we can get the data for each channel. We will create similar functions for the other channels as well. Let's rename this to rank 2. The rank 2 is configured for channel 4, rank 3 is for channel 7, and rank 4 is for channel 8. We also have different sampling time for all the channels. Comment out the pre-generated code for the channel initialization, so to avoid the conflict. Also copy this channel configuration structure definition, and paste it inside all the functions. Inside this function, we will just change the channel to channel 4, but keep the rank to 1. Also configure the sampling time as per the CubeMX configuration. The rest of the code for reading the ADC data remains the same. Now for reading the rank 3, we will change the channel to channel 7, keep the rank to rank 1, and change the sampling time as per the configuration. Finally, for the rank 4 function, set the channel to channel 8. The rest of the code remains the same. Basically, we have created different functions to read a single channel data for individual channels. Now in the main function we can simply call the particular function to read only one channel. We will test it by reading only rank 3, that is channel 7. When we were using the discontinuous mode, reading rank 3 was not possible until we had read rank 1 and 2. But with this method we should be able to read rank 3 without involving other channels. You can see that we are getting the data for rank 3. Let me vary the potentiometer 3. You can see the variations in the ADC value. This means that the rank 3 is being read properly. I am leaving the value at around 40,000, just remember this, as it will come handy when we read all the potentiometers together. Now we will do another test, where we will only read the rank 4. Here we are getting the value for the potentiometer 4. Now I am varying the fourth potentiometer, and you can see the variation in the ADC value. I am going to leave this value at around 60,000, just keep this in mind too. Alright, now we will read all 4 ranks at once. Let's build and debug the project now. You can see that we are getting the data for all 4 channels now. The rank 3 is at 40,000, and rank 4 is at 60,000. These are the same values which we set while testing the channels earlier. I am rotating the first potentiometer now, and you can see the variations in the first element of the array. Similarly, when I rotate the second potentiometer, you can see the variations in the second element of the array. So the code works fine, and we are able to read the individual channels at our wish. Basically, you can call the individual function to read a particular channel data at any point in the code. This method is more practical than reading using discontinuous mode. If you want to read all the channels at once, better go with DMA. This is it for the video. You can download the project from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.